Hi everyone, in this video we're going to look at how to divide polynomials using long division and another technique. So recall that rational expressions are just quotients of polynomials. So it's a polynomial divided by another polynomial. Let's see what happens when we divide a polynomial by a monomial. Remember, a monomial is just one term. The prefix mono means one. So when you have a polynomial and you're dividing it by one term, a technique you can use is you can just take the polynomial and split it and divide each term by the monomial. So if I have a plus b divided by the monomial c, I can just split this and make it a divided by c plus b divided by c. So let's take a look at some examples right here. In this first example, I have this polynomial, it's a trinomial, divided by a monomial. 5x is just one term. So I'm just going to take each of the terms and divide them by 5x. Now what I'm going to do is divide my coefficients. 10 divided by 5 gives me 2. And remember, when you're dividing like bases, you subtract the exponents. And there's actually a 1 here, so 3 minus 1 gives me 2. 5 divided by 5 is 1. In this case, it's negative. And x squared divided by x is x. 20 divided by 5 is 4. And x divided by x is 1, so it goes away. So there's your answer. In letter B, again, we're dividing. This time it's set up for us. And we're dividing by that monomial x squared y. So again, I can take each term and split it. And now I'm just going to divide my coefficients. 3 divided by 1 is 3. X to the 5th divided by x squared is x cubed. Y squared divided by y is y. Minus 15 divided by 1 is negative 15. X cubed divided by x squared is x. Y divided by y goes away. X squared divided by x squared is 1. And negative 6 divided by 1 is negative 6. And if you notice here, the exponent on the bottom is bigger than the one on the top. So when that happens, think of it as like bottom heavy and top heavy. If it's bottom heavy, if the power on the bottom is bigger than the one on the top, you're going to place your answer on the bottom. So here I have 1 minus 2, which would give me x to the negative first. You can't have a negative exponent. So to make it positive, you place it on the bottom. So it'll be x to the first on the bottom. So think of it like this. If you had like x squared over x, we know that's just x to the first. It's top heavy, the power up top's bigger than the one on the bottom. But if I was to do the reciprocal, x to the first divided by x squared, when you subtract them, you get a negative 1. And we're not allowed to have negative exponents. So what we do is we take a 1 and then we place the x to the negative first on the bottom and it becomes positive. So just remember, when it's top heavy, exponent up top's bigger than the one on the bottom, your answer goes up top. Just pretend this is over 1, so it's on the top. When you have an exponent that's bottom heavy, you're going to place your answer on the bottom. 2 minus 1 is 1, so it goes down there. So that's why I placed the x here, because it's bottom heavy. And then the y, there's nothing to simplify with the y. That's just going to stay where it is. So that's your final answer. And remember, the answer to a division problem is called a quotient. So these are the quotients. Okay, you can try this one on your own. Let's look at another technique that we use when we're dividing by polynomial other than a monomial. So let's say we have a polynomial divided by a binomial. We can't use the same process. So one technique we can use is long division. Okay, let's review what long division looks like. So let's say I had 25 into, let's do 5,234. So the first step I'm going to do is I'm going to divide, okay, 52 by 25. And 52 divided by 25 goes in 2 times. Okay, so first I divide. Then I'm going to multiply 2 times 25. So my next step is multiply. 2 times 25 is 50. And then my next step, after I multiply, is to subtract. I want to subtract these. And when I subtract 52 minus 50, I get 2. And my next step is to bring down. So I'm going to bring down the 3. And then repeat. So you start the process all over again. So I divide, multiply, subtract, bring down, repeat. An easy way to remember that is with this phrase, dead mummies smell bad roasted. So you have DMSBR. Divide, multiply, subtract, bring down, repeat. Okay, so we would keep doing that. So then I'm going to divide all over again. 23 divided by 25 is just 0, right? 25 can't go into 23. 0 times 25 is 0. Then I subtract, and then I bring down, and then I repeat. 234 divided by 25. So that goes in about 9 times. And then 9 times 5, 5 carry the 4. And then I'm going to subtract. And then that 9 is my remainder. And we would write the remainder over the divisor. So your final answer is 209 and 9/25. We're going to use a similar process when we're dividing polynomials. So I'm going to take my x plus 2, that's my divisor, it goes on the outside. And then the 2x squared minus x minus 10 goes on the inside. And you want to make sure that there's a spot for everything. So if my highest exponent is x squared, I want to make sure that there's an x to the first and then a constant. If it was x to the third, I'd want to make sure there was an x squared, an x to the first, and a constant. So there needs to be a place for everything. If there's not, you're going to put in a 0 for a place filler. And we'll see that come up in the next example. So the first thing I'm going to do is I'm going to divide. And I'm going to divide this first term by this first term. So 2x squared divided by x gives me 2x, which I'm going to place right above the x column. So you want it to line up. Now I'm going to multiply. And when you multiply, you're going to multiply by whatever is in the divisor. So it's 2x times x and 2x times 2. 2x times x gives me 2x squared. And then 2x times 2 gives me 4x. After you multiply, you subtract. So when we're subtracting a quantity. So I need to put parentheses around that to indicate that I'm subtracting not just the 2x squared, but the 4x. And think of subtraction as just adding an opposite. So what I want you to do is change the minus to a plus and then change each of the signs, just make them opposite. Now you can just combine vertically. So 2x squared minus 2x squared, that's just going to cancel out. Negative x minus 4x is negative 5x. And then I'm going to bring down the negative 10. And then I repeat the process. So now I'm going to divide the first term by the first term again. Negative 5x divided by x gives me negative 5. Then I multiply. Negative 5 times x, negative 5 times 2. I'm going to subtract. And remember, when you subtract, you're adding an opposite. So you're going to change the minus to a plus and change all the signs on the inside to the opposite. And as you can see here, everything just cancels out. So your remainder is 0. So your answer is just 2x minus 5. That is the quotient if you were to divide them. Let's try letter B. So in letter B, I have my x squared minus 1 is my divisor. And on the inside, I have 3x to the fourth plus 2x to the third. And then notice that there is no x squared. So I need to put a 0x squared as a placeholder. And then I have minus 8x plus 6. And now you're going to start the process. So we're going to divide the first term by the first term. 3x to the fourth divided by x squared is 3x squared. So do you see how if that 0x squared wasn't there, it wouldn't line up? Everything needs to line up. So x's need to line up, x squareds need to line up, constants need to line up. Okay, I divided, now I multiplied. 3x squared times x squared minus 1 would give me 3x to the fourth minus 3x squared. And remember, you're subtracting, which is where you need to make the minus a plus and change the signs on the inside. And these terms will cancel. Okay, I am going to bring down my 2x to the third because really there's just a 0 here that you're adding it to. And 0x squared plus 3x squared just gives you 3x squared. And then I'm going to bring down my negative 8x. And then I'm going to repeat. So again, I'm going to divide the first term by the first term. So 2x to the third divided by x squared just gives us 2x. And then I'm going to multiply 2x times x squared and 2x times negative 1. And again, keep in mind that the first terms always need to be the same so that they'll go away. If you noticed in the last problem, the first terms always ended up being the same, but they are opposite signs, so they'll cancel. Okay, and here when you're subtracting a quantity, you can change the minus to a plus and change the signs on the inside. So the 2x cubes cancel. I'm going to bring down my 3x squared. Negative 8x plus 2x gives me negative 6x. And then I'm going to bring down the 6. And then I'm going to repeat. So I'm going to divide 3x squared divided by x squared, which gives me just 3. Multiply. And then I'm going to change the minus to a plus, change the signs on the inside. And I get negative 6x plus 9. This is your remainder. So what I need to do is just put a plus and take my remainder and place it back over my divisor. So your final answer is 3x squared plus 2x plus 3 plus negative 6x plus 9 divided by x squared minus 1. And you can try the next two in practice. And if you have any questions, please feel free to reach out to me. Hi all, in this next part of the video we're going to look at polynomial functions and we're going to find the zeros and state the multiplicity and determine if the graph will cross or touch at each zero, and then also look at the end behavior. So in this first problem here we have this polynomial and I want to find the zeros, which remember just the x-intercepts. So I'm going to take my expression and just set it equal to 0. And remember that we're going to apply the zero product property, which just means take each of the factors and set it equal to 0. I don't have to worry about setting 1/10 equal to 0 because it doesn't, right? So we're just going to take x minus 2 to the third and make it equal 0, 2x minus 1 equals 0, and x plus 2 squared equals 0. And my exponents tell me my multiplicity. So here we know we're going to have a repeated root of 3. It's going to be a multiplicity of 3. That just means that when you solve this and set it equal to 0, it has 3 answers that are the same. So if you solve for x here, you're going to get 2. But because of the 3, there's really 3 2's. So x equals 2 has a multiplicity of 3. And then 2x minus 1, if I solve that for x, I get 1/2, and that multiplicity is just 1. And then x plus 2, if I set that equal to 0 and solve for x, I get -2, and that multiplicity is 2. Okay, and again, the multiplicity comes from the exponent. Okay, so now the multiplicity also tells me whether the graph will cross or touch the x-axis at that point. So remember, if the multiplicity is odd, it's going to cross the x-axis at that point. So the 2 odd multiplicities would be this here, because it's 3 is odd, and this here, because it's got a multiplicity of 1 is odd. So it's going to cross the x-axis there. So here it's going to cross at x equals 2, and here it's going to cross at x equals 1/2. And you'll see that in the graph. And then even multiplicity means that the graph is just going to touch the x-axis at that point. So it's going to touch the graph at x equals -2. So you're going to see here, if I pull up the graph, you can see here how it's crossing at 1/2 and at 2, because those both had an odd multiplicity, and it's touching the x-axis at x equals -2. So it's kind of hitting the -2, and then it's bouncing off. And this is going to be useful when you're graphing polynomial functions, okay, in addition to finding the end behavior. So that's the next thing I need to do. So I found the answer. My zeros were 2, 1/2, and -2. And then it crosses and touches at certain points. And then letter C is the end behavior. So for end behavior, remember, I need to know 2 things. I need to know the leading coefficient, if it's positive or negative, and the degree, if it's even or odd. So my leading coefficient here, right, I would have a 1/10 x and then a 2x and an x. So if you multiply them, you would get 2/10, and then it would be x to the 6th power, because you have an x cubed, an x to the 1st, and an x squared. So if I add those, I get x to the 6th. So my degree is 6, which is even, and my lead coefficient here, it's positive, right? We said positive 2/10. So when it is positive and even, remember that it's going to point upwards on both sides. So think of x squared, right? It's positive and even, and it's a parabola that's concave up, so it's pointing up. So when I write my end behavior, I'm going to express it like this. I'm going to talk about the limit as x approaches positive infinity of f of x. So that just means on the x-axis, so if we look at the graph, if we were to go towards positive infinity on the x-axis, what is the graph doing on that end? Well, on the right side, it's pointing up. So f of x is always going to approach positive infinity. So this is going to equal positive infinity. And the limit as x approaches negative infinity just means as you are walking along the x-axis towards negative infinity, again, if you look at the graph, what's happening to the graph? It's always increasing towards positive infinity forever. So the limit here is going to also equal positive infinity. Anytime you have, you're talking about end behavior and it's positive and even or negative and even, you're going to get the same answer for both limits, okay? Because remember, both sides are going to be going in the same direction. It's when you have odd powers that it's going to go opposite. So you'll get two opposite answers. One will be positive infinity, the other will be negative infinity. Okay, let's try one more. So here we have f of x equals x cubed minus x squared minus 2x. So the first thing I need to do is find the zeros. So I'm just going to set this equal to 0. Okay, and this is not factored for me like letter A was. So I'm going to go ahead and factor it. And here we can factor out an x, and you're left with x squared minus x minus 2. And then I can also factor the inside here. So two numbers that multiply to give you -2 that add to -1, and we get x minus 2 times x plus 1. Okay, and I'm going to set each of these factors equal to 0. And here, as you can see, we don't have any powers other than 1. So for each of those, it has a multiplicity of 1. 1 is odd, so that means it's going to cross. So it's going to cross at x equals 1, it's going to cross at x equals 2, and it's going to cross at x equals -1. So here are your zeros, and it's going to cross in each place. So if we were to actually graph that, you'll see, so if I plug in here, I have my x cubed minus x squared minus 2x. You can see at each of those zeros or x-intercepts, the graph goes right through and crosses. Also take a look at the end behavior. It is going in opposite directions, right? And that makes sense because our degree is a 3, it's odd. So when we're looking at end behavior, my lead coefficient here would be 1, so that's +1. And my degree is 3, which is odd. So remember, positive and odd, the right side's going to go up, the left side's going to go down. They're going to go in opposite directions. So here, if you go to the right on the graph as x approaches positive infinity, f of x is also going to approach positive infinity. It's going to point up. And as x approaches negative infinity, as you go left on the graph, that's negative infinity. Let me make that more clear. F of x is going to approach negative infinity. So they're opposite for that one. Okay, and you all can try the next problem on your own if you take a look at those examples from above. And in this last problem here, we have a function, okay? And again, you can try this on your own, looking at the examples from above. So you want to talk about how many turning points does this have? You want to find the y-intercept algebraically. We talked about all of that in the last chapter and before. Find the zeros or the x-intercepts and their multiplicity, and then discuss the end behavior as well. Okay, and the only other thing I want to point out to you are what power functions are. There are functions of degree n, and they're in monomial form. So mono means 1, right? It's one polynomial. Okay, it's going to resemble something like this. So if you had like x squared, that's called a power function. Negative 5x cubed, 1/2 x to the 6th. Okay, and what's important to remember is that polynomials resemble a power function when you have large values of the absolute value of x. specifically with end behavior. So x squared, I know it's positive and even, so the graph, remember, is going to go up on both sides. So if I was to take x squared, a power function, and let's say add on to it, like something like this, if you graph that equation, it's going to resemble the power function. So even though it will look slightly different, it'll go through the x-axis in different places, it's going to contain the same end behavior. It's going to approach positive infinity as x approaches positive or negative infinity. Okay, just like this one is negative lead coefficient and it's odd. So remember, negative and odd, it's going to point up to the left and down to the right. Okay, so even if I created another equation using that power function, like something like this, it's going to contain the same end behavior. Okay, that's it for this lesson. Please feel free if you need to go back and review to do that. If you have any questions, please reach out to me.